Okay, so if you took 30-1 last semester or you're taking it right now, this will be about 90% review. Just a couple things, or one kind of thing that's a little bit in more detail. So let's go through this pretty quick. My 30-1s just went through this stuff, so they quite familiar with it. Okay, so let's just get all, for those people that definitely took it last semester, let's talk about all these things. Now, angles are created by rotating an arm, right, from the positive x-axis. So you're always going to be starting here. So the initial arm is where you start. The terminal arm is where you finish. Okay, Sarah? Let's go here. Now, counterclockwise angles are positive. So this direction is positive, and counterclockwise are negative. Angles can be measured in degrees or radians. 2 pi radians equals 360 degrees, and pi radians equals 180. Just remember that your quadrant numbers, this is 1, 2, 3, and 4. Okay, so if I gave you an angle like this would be the terminal arm, right? And we started from here, so this is the initial arm. Pretty basic stuff. You do this stuff in grade 11. Okay, then we have our primary trig ratios. Now, when we have any single radius on a circle, that can always be made up into a triangle. And this triangle would have dimensions x and y. Now, this is your angle. So it follows along with SOHCAHTOA that if you're doing your sine, it's opposite over hypotenuse. If you're doing cos, it's adjacent over hypotenuse. And if you're doing tan, it's opposite over adjacent. And those will correspond with the y over r, x over r, and y over x. Just remember that r, the radius, since this is a right angle triangle, we can use Pythagoras, and that would be x squared plus y squared. And we're always going to make our radius positive. The x or y will be positive or negative depending on the quadrant they're in. Okay? If they're in quadrant 2, your x's should be negative there. Right? Now, the reciprocals. So we've got cosecant is 1 over sine, also known as r over y. Secant theta is 1 over cos, and that is r over x. And cotan is 1 over tan, therefore x over y. Okay, and then you can always remember which one belongs with which, because there's only one co per pair. Now, cotan and tan, no one screws up, right? But cosecant and sine, sometimes they're putting cosecant with cos, but there's 2 cos there, so you know they don't belong together. Secant and cos, 1 co there in the cos. Cosecant and sine, 1 co in the cosecant. Again, just did that with 30-1. Coterminal and reference angles. Okay, coterminals are 2 angles, actually infinite number of angles, but that have the same terminal and coterminal and same terminal arm. So if you had this angle or this angle, as well as you could do this angle, since they all stop in the same place, they coterminate in the same place. And the way we usually do it is it's the principal angle plus 360n. So we can say angle 2 is angle 1 plus 2 pi n is in the integers. And this is always the principal angle, which is an angle, positive angle less than 360 degrees. Now, a reference angle is always acute, less than 90. It can also be 90 as well. And it's between the terminal arm and the nearest x-axis. Okay? So this would be my reference angle. This is what I would call my rotation angle. Okay, now I'm not going to go through using special triangles. I'm just going to go right to the unit circle. Now these are called special angles, but they are your most common. They go by every pi over 6 and every pi over 4. It's crucial that you know all of your radians quite well and you know every coordinate. Okay? Now there's many different ways to be able to memorize these. If you start here and you work your way down, it goes 0. It's actually could be root 0 or root 1, root 2, root 3 to 1. Okay, so it actually goes 0, 1, 2, 3, 1. You can see everything is over 2 here, and you can count back up 1, 2, 3. It makes sense to me that here the x should be longer than the y for this triangle, and here the x is bigger than the y. Now, other things that we should add is that this is always the cos. This is the sine, cos, sine, cos, sine, cos, and sine, cos, and sine. So when I ask you for cos pi over 6, you give me the x value, root 3 over 2. If I ask you for sine pi over 6, that is 1/2. If I asked you for tan pi over 6, that is sine divided by cos. Now you can work that out every time, or you could just learn that it's root 3 over 3. For 45 degrees or pi over 4, we would expect tan to equal 1 because root 2 over 2 divided by root 2 over 2. And then tan here is root 3. At 0 degrees, since it is 0 divided by 1, tan would equal 0. And at 90 degrees or pi over 2, that would be 1 divided by 0. So tan would be undefined here. Okay, now I guess the trick is to really know quadrant 1 well, and all of these reflect across the x and reflect across the y. Put the signs on for if in quadrant 2 all x's should be negative, right? Therefore, all of your tans would be negative too, because you're always dividing by cos. That leads us to beside here the cast rule, right? That is what is positive in that quadrant. And just again to reiterate, it's always x comma y, which is cos theta sine theta. Okay, and that's with a radius of 1. Okay, so if radius is 1, those will be the okay, so I just said that exact thing that's in there, cos theta equals x, sine theta equals y. I think the chart is kind of redundant here. I mean, they're all up here if you need them. So why fill in the chart? I guess we could have put the tans in there, but we have them on our chart now. Okay, so let's just do some questions here. It's a pretty short lesson. Okay, this one says to write as a function of their related acute angles. Okay, now for every one of these, I would encourage you to draw it quick, to always get your cast rule bearings and your reference angle. Okay, so I got sine 120. Okay, so 120 is about there. So you want to draw that. Okay, so we're dealing with sine here. Okay, so sine will be positive. So I'm going to put positive sine, and then I will put the reference angle in there. The reference angle is always the angle between the x-axis and the terminal arm, and that is 60 degrees. So positive sine 60 degrees is the same thing as sine 120. So I have rewritten that as an acute angle. Somebody make a funny trig joke. Okay, negative 2 pi over 3. Now, if you're not good at the radians yet, it would be a good time to start. Now, I always put them over 6 because every 30 degrees or pi over 6, right, then I know how to be able to count them around. Now, so I think of this as negative 4 pi over 6, and then I just count 1, 2, 3, 4, and I'm right there. So this is negative 2 pi over 3. So that would be my rotation angle. Okay, there are, so this way would be 2 pi over 6, or pi over 3 would be my reference. So I put my cast rule. I'm looking for sine in quadrant 3. So sine is negative. Okay, and if you want, draw an arrow there because that's where you got the negative from. Maybe we'll draw an arrow there. These are our notes, right? You want to know where'd you get that from? That arrow's going to tell you. So negative sine pi over 3. And of course, you can always test these by putting them in your calculator and making sure you get the same answer. Okay, cos pi minus pi over 3. Now, there's two ways to do that. You could go pi and then come back to pi over 3. You can just do the math, right? This would be 3 pi over 3 minus pi over 3. So this is the same thing as cos 2 pi over 3. Okay, again, now I think of that as 4 pi over 6. So then I just go 1, 2, 3, 4, right there. Okay, so that is 2 pi over 3. I write down my cast rule. In quadrant 3, cos is negative. So I got a negative, because I'm over there, cos, and then I just put my reference angle here. My reference angle would be 2 pi over 6, or pi over 3. So cos, negative cos pi over 3. Okay. So tan 2 pi minus pi over 6, just got to do a little math. Okay, so that's tan 12 pi over 6 minus pi over 6. So I'm looking for tan 11 pi over 6. Okay, now there's 12 pi over 6s as you go all the way around, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I am right here. That's my 11 pi over 6. So the reference is 1 pi over 6. Put my cast rule. So in that quadrant, tan is negative. So negative tan pi over 6. Okay, so I just want to, so that's should be, I just want to add one more example here. So we're going to do this one, sine pi over 2 minus x plus sine pi minus x plus sine 2 pi minus x. Okay, so we want to write it as one trig ratio. So when you do all this, it does equal cos x. Let's write that a bit higher. Now, if you look on your formula sheet, you have tons and tons of, this is all trig, the first page, and then goes a bit to the other page. Okay? So this has no derivatives on it or anything yet, because you're going to have to know the derivatives, sine, cos, all that stuff. But all your identities are on here. Now you get to use this, obviously, on a test. But if you haven't used it, you're going to have to try and find things that maybe you didn't. Okay, so if you see, it says sine pi over 2 minus x, this equals cos x. Okay, and if you look at sine pi, now some of these too, like there's a, like on your sheet, it says that sine pi minus x equals sine x. Okay, so what's that saying? They're saying that sine x, say this is x right here. They say that's the same thing as pi, which is all the way around, minus x. They're trying to tell me that this would be the same as that. Now, if you think about it, the y values are identical there, aren't they? Right? So that's where that identity comes from. So these are all done by the unit circle, and I could show you how sine 2 pi minus x equals negative sine x. Okay, so that's another identity on there. Okay, so I'm going to put plus sine x because I just showed you that that works. And then another one is sine 2 pi minus x equals sine negative x. Okay, so if you go 2 pi minus x, 2 pi minus x, you end up there. And if you go sine negative x, you end up there. Okay, so that's why that one shows that they're the same. And then there's another on your negative angle identities, that sine negative x equals negative sine x. And it shows that in that quadrant, sine is negative. So if you put me in the third or fourth quadrant, I will be like negative sine x. So I showed you how here goes to here, and this you could prove here as well. So then this is minus sine x. And cos x plus sine x minus sine x just cancels. Now, all of this is on your formula sheet, right? You just don't want to be using it for the first time on your exam. You want to be pretty familiar with where everything is. It's kind of like, using the periodic table, right? If you use it enough, when you get asked a question on a test, you're not going to be hunting all over for oxygen. You probably have oxygen memorized because you use it so much, okay? Here's our homework. Do you guys have that written down? Okay, good. Okay, so the point of this question 5 is to make sure you're really looking at this a lot. There's going to be some questions in there. Super easy stuff, but without this, you'd have to try and prove everything just like I tried to show you. Hmm? Just let me stop my recording here and then I'll help you.